Hello and welcome back to another episode of Teardown Tuesday. Today we've got an interesting board, and we're not going to talk so much about the board as we are about what's on it. So in this case, this particular board is sort of like a breakout board. It doesn't have any processing on it, but it's being used to interface the controls to the components. And the way that it does that is with a series of relays. Now, relays work a lot like contactors, in that what we're doing is applying a small voltage to switch a larger voltage. So in this case, we've got all these small ice cube relays, and then we've got this larger relay here that's actually in a socket and we can pop off the board. And this is a good example of how boards work at a large scale. So these are the interfaces from the processing side of the board to the component side of the board. And it won't always be an ice cube relay, but sometimes you'll see solid state, where it's actually a small electronic component making that switching action. But in this case, it's really clear how it works because it's all mechanical. So let's go ahead and get this off, and then we'll take this relay apart and go over how it works. Alright, so right away we can see that there's some damage around this pin of the socket. So whatever load was being carried by this particular relay, we know that it was enough load to heat up this connection. You can just start to see the base of the relay melting. Let's try it like that. You can see the discoloration. There's a little bit of pattern around it from that load moving through that terminal. So we'll set the board off to the side and let's take apart the relay. So looking around the outside, we see a number of ratings here, but they're really hard to read because of the way they're situated. So let's get this cover off and then we'll try and read the ratings. Alright, so we've got the cover off, and you can see a lot of discoloration around the load terminals here. So this relay was definitely worn out, and in fact its switch plate has welded. This plate should be able to move freely, but you can see the contact terminals have welded and it's stuck now. It does not move freely anymore. So what that would have done with those stuck contacts is it would have continuously energized multiple terminals, which is a recipe for trouble. You'll blow fuses, you'll damage components, you have all kinds of problems. Alright, so now that we've got this cover off, we can start to see the ratings a little more clearly. And you can see first up here a number of ratings: 24 volt DC, 25 amp at 300 volt AC, and we've got all these different amp ratings for the load side, but the coil side of this is the 24 volt DC up here. So now, down at the bottom is the terminal layout. So you can see the terminals are numbered 1, 3, 4, 6, 7, and 9. In this case, the reason we're skipping numbers is this relay does not use the center terminal stack. And then at the bottom we have A and B. And A and B are drawn with this squiggly line in between to represent the coil. So when we energize A and B with 24 volt DC, the coil would engage. And you can also see the description of the plate inside the relay. Which terminals are normally open and which terminals are normally closed, and then which ones are common between. So now, taking a look at the actual relay, we've got a couple things going on here. And the first thing, the one that you can't see, is the smell. So this particular component and the way it burned up, it has an odor to it. Something in here is very badly melted, and I can smell it, but be glad that you can't. we've got a couple things here. We've got this spring plate on top, we've got a coil down here, and then we've got our contacts. And you can see the common terminals, which were 7 and 9, have these wires that are soldered on, so that no matter what position this plate is in, those are common. They're always in the circuit. So we can see here where these terminals have become welded. And I'm going to try and get this apart, but I'm probably going to end up breaking it. Alright, I think I've got it broken loose enough I can take the spring plate off. Yeah, there we go. So in normal operation, this spring plate moves when it's energized. So the coil energizes and it interacts with this steel plate and it pivots back here at the back and the contacts can move. But in this case you can see the damage to the electrical contacts here is so severe that it actually welded itself to the contact pads. And that was the failure of this relay. Yeah. You can see the buildup is pretty significant there. It was enough that it couldn't even swing once we had it broke loose. But that's the basics of a relay. We've got an electromagnet, a steel plate that can move, that can swing, and we've got our contact pads. So when we look at a relay, principles at play, we've got electromagnetism, and then when we look at how it fails, the two big failure modes are either the coil burning out down here or the contact pads becoming damaged up here. And that's the basics of an ice cube relay. Alright, thanks for watching. Hi folks, my name is Jack Kell and I'm a Senior Technical Trainer for SmartCare. The video you've just watched is part of a larger series of technical training videos we make available to our technicians at SmartCare. If you found this interesting and you'd like to see more, please subscribe. I'll be releasing a new component teardown video every Tuesday in 2022. If you're already a SmartCare technician and you have a part that you'd like to see me tear down, please reach out to me internally for shipping instructions. If you're not a SmartCare technician, but you or someone you know would like to learn more about a career as a service technician specializing in commercial restaurant equipment, please check out our open positions at www.smartcaresolutions.com/careers. Thanks for watching.